of about 11,000 metric tons of structural steel involved in this in total. But none of the structure is with the floor plates or the columns. It is only for the stability of the building. The building is in concrete. And this one is Kingdom Trade Center in Saudi Arabia, where the overall height of the building is 300 meters. The last 120 meters is what you are seeing as like a needle hole. And it is completely non-occupant. All the 120 meters there is no flow. So the floors are only 180 meters, which is completely done in concrete. What you are seeing is the 180th meter. Over that only the structural steel comes, and all the 120 meter above is only for roof feature of the building, and it has only a panoramic view bridge at the top. So because there is no concrete on the 120 meter, the entire structure is subjected to wind and all the time in tension. It's because it does not have a counterweight to balance it. And this is the Tekla and Bocad model together. The bridge is done in Bocad and the entire other structure is done in Tekla. And at any point of time, in the bottommost necklace point, where the joint has 13 members together and 19 members at one particular joint. So if you see that, when we were there for constructing, when we were entering into the project, the tower cranes on either side have been fixed and the construction is happening, where the tower crane can lift only 8 tons maximum, whereas the bridge, which is going to be at the top, is 180 tons to lift as structure alone. So we have planned in such a way, we have assembled on 188th meter, and then we lifted by having like two other side, we have taken up like a column, and then we lifted the middle portion with the bridge as what you are seeing now with the stand jacks. This is the way. And here also, the 120th meter when we start lifting, the entire column started buckling. So in terms of analysis, so what we have done is we have lifted in 2 stages at 60th meter, and we have strengthened the necklace bottom like this, and then we have lifted again to the next. And when we are doing in position, we have completely welded one side to allow the other side for thermal movement, and we have connected all the 4 joints again, 4 cards at one time, so that to avoid the differential movement of the expansion. So that is the way this has been constructed. And here also there is, even though we have used about 7,800 metric tons, none of the steel is used for the floor planes. It is only for the roof feature. And you can see one of the connections which has 13 member connecting at one single joint. And these are some of the connections where even you cannot apply any of the spreadsheets, which has been derived from the basic principles. And this is Kipco Tower, which is a standard building but has its own complexity, which is being in diagram. And this building is done in Qatar. And central circular core, and the diagram is the column and the perimeter. The span is 14 meters from the core to the end. So this 14 meters is really very much helpful in terms of an office to plan properly. So that is the reason they have selected structural steel for this. Even though there is one more neighbor building has been taken up in concrete. If you see in Qatar, there is one more building in concrete completely into similar diagram fashion. Whereas they have started 6 months ahead, whereas we have finished 6 months ahead. So that is the way that it has been done. And this is the in fact, even pre-assembly in our factory, we have done that, whether the pieces are getting matching or not. And that is the way that we have done. We have done in our Dubai factory, and we have transported to Qatar. And all the floor beams are having even MEP openings for the floor requirement. And it has the inclination from the bottom towards the center and opens up again at the top. So that is Kipco Tower, and that is an office building again. Tiara is another office building which is there in Sheikh Zayed Road. One is the hotel tower, one is an office tower, which has again a central core and perimeter columns, and there is no in-between floor columns. So the span is about 14 meters in one side and 12 meters in other side. So which was very efficient in terms of office space. So they have gone for the structural steel option because of that. And also we have constructed well ahead in schedule, and we have used about 4 days cycle per floor to construct that. And Rose Rotana is another hotel tower which is right now in operation, but we have done in a record time of 24 months, 75-story building. 30 meter by 30 meter is the floor print, and it has a core at middle width is only 10 meter by 10 meter. The entire column is not even composite because the space restrictions, they have gone for jumbo sections of 1080 kg per meter jumbo sections to make this column so simple and slender. So these columns are completely being used with, in fact even they have used the bottom with a cover plate to make a box, and later it has been just opened up and it is a rolled section. And it is a 30 meter by 30 meter floor print. It's a hotel. Have 4 transfer girders at the middle. And you can see in the middle that there are double-story transfer trusses and belt trusses to take care of the drift of the building. And the roof is again a steel. It is very elegant in terms of steel, but it is quite complex to have this kind of roof geometry. And this is the Tekla model, and the other side is the actual construction of the same building. And Snow Center is Dubai. In Dubai, it is a mall where as what I earlier said, between the 2 square 4 columns, the space is 54 meter, and across is again 54 meter, which is almost like a football ground. And the entire construction has happened with the trusses spanning from one side to another side, and in the same inclination, but one side starting at the ground, and it has been about 12 meter on the other side. You can see temporary supports being erected in the same height so that individual trusses can be supported. And during that time, we were cantilevering the other side with the temporary structures to make that truss. And this was the assembly in progress. And once that is done, even we have concreted the floor and cladded as well in the ground to avoid the latest scaffolding when it is in position, which is almost 70 meters above the ground. And we have used 4 towers on 4 corners, and each has 1,000 ton capacity synchronized jacks to lift the entire structure. When we were lifting, the structural weight is 3,000 tons. It is one single lift. 3,000 tons that we have done that, which includes of concrete and cladding. The structural steel alone is about 2,000 plus tons. So this is what the progress, you can see that. So this is what, when it is getting lifted. We started the first day morning, and then we have ended up with the second day, in position. So it's about 48-hour operation to lift that, and then we were monitoring also the wind for almost about a month to see that when it can be lifted, when we were doing. So in terms of projects in India, we have done, airports, where about Southwest Pier and the mega columns have been part of ours. Even though it cannot come under commercial classification, just what we have done, that I'm just putting it up. It's a 2.3 meter by 2.3 meter mega column, which is being done with the plate built-ups. And Trump is another tower, which is that's what initially I said that. Even now the developers have started inclined towards residential building in structural steel. This is one of the structural steel building in Mumbai, 67-story, which we are right now doing for residential building. Even we are, as what Kamal sir earlier told, in his presentation, we are using here slim floor deck, which is a deeper deck, to make sure that the depth of the beams are very limited because of the architectural impressions. So we are using that in this particular project. And Marathon Future X is actually a 44-story building, is a commercial building. And of course the power plant structure which we are doing this. In fact, when we are entering into Marathon, they have done about 5 floors with concrete, and internally that we need to erect structural steel. So it was quite challenging because none of the cranes that we can take it up for our material lifting. So we have gone with our old method, and then we have done this, which has metal decking as well as concreting together. And right now the structure is waiting for its next level approval. As earlier our friends have told, doing that in 24 months or 36 months is fine. But the problem what we are facing in India is approval on high-rise committees. So once, if it is very clear, construction of the building is not at all an issue. In terms of steel, we can do with say 3 or 4 days cycle for the structural steel columns and beams, and for the core with 6 days. Because the job which I am telling you earlier, the 67-story building, we are using first time in India with the jump form techniques, and that is going to achieve almost 6 days cycle of a core per floor. That is what we are aiming. So international technologies have been incorporated, and then construction is being started in India with that kind of thing. So time is not at all an issue. Whether say the proper the overall integrated things that whether we are looking at or not is the question now. In terms of fabrication, this is our Dubai factory, this is our Sharjah factory, and which has all state-of-art facilities. And this is having a pre-assembly yard. And in India, we are having a factory in Trichy, which has been